Hello, this is Pat Cleet with TII Technical Education Systems, here to talk to you about their MB100 Fundamentals of Electricity Training. You're going to notice right when you pull this out of the box, like all of their fundamental technology trainers, that this comes in a very sturdy case and is only a couple of minutes from arriving at your school to being ready to use in the classroom. So let's go ahead and take a closer look at this system and see all the advantages of using the MB100 in your classrooms, how it'll benefit the school and the students. Let's go ahead and take a close look. Like all of the fundamental technology trainers that TII offers, it comes with a user manual that is ready to go. The MB100 provides all of the information that a student needs to go from having zero knowledge about the principles of electricity to having a good understanding of the basic circuits and components that are required. The book is set up like all of them, where you talk about individual components. They have you actually building things and applying this, and then at the end they start to walk you through the physics of it, the actual real mathematical understanding of what's going on. So students don't get bored up front with just learning theory. They're learning practical knowledge right away. And that's a really great way for these students to learn, because once you understand what you're doing with your hands, then you can begin to understand what is happening at the scientific or the physics level of an electrical circuit. So let's take a look inside of here. The first time you open up the MB100, you're going to have to get this set up. And this only takes a couple of minutes. And once it's set up, there's not a lot of work that the teacher will have to do when it goes from student to student. So when you open it up, you're going to see that it comes really packaged, so you know the equipment's going to be good. It comes with some very basic parts that students are going to need to understand what's happening inside of an electrical circuit. Then we have the packaging equipment, the stuffing. You can keep this if you want. If it's going to travel around with you from classroom to classroom, from school to school, it might not be a bad idea to keep this, but we'll set it aside for now. So the equipment can be either permanently installed, like the capacitors and different electronic components, including the motors, or they may have a place that's identified with these types of Velcro systems. And so what this allows the instructor to do is to very quickly be able to assess if anything is missing from the trainer. This is really important because it allows easy transition for one student to another in different periods, different class times, different locations, all sorts of things. All right? So let's go through some of the components that are located in here and find their place. So the first thing you're going to see is an analog meter. It comes with the Velcro, so it has a place that's identified right here for quick visual inspection. The electronic breadboard, which is very useful for hooking up some of the more advanced circuits. The magnet, so they can begin to understand how electricity and magnetism interact with each other. And then there's a component basket in here that you can add the components however you feel is going to work best for your classroom. And then some of the components can stay in a loose bag, or you can figure out how you want to lay the system out and what's going to be best for your class and your students. Okay? So now, to get this thing plugged in, we're just going to run this to a 120 outlet, which makes it extremely versatile because that's all you need. You need this container, and you need access to 120 volts, and this trainer can be used anywhere. The MB100 comes with not only all the things that students will be hooking up, but also with some of the components and different really creative ways to show some of the basics of magnetism and its relationship to electricity. So for example, there's a number of metal shavings in here that when you put the magnet on, give it a little shake, you will begin to see the magnetic field forming, okay, at the north and the south, and as you shake it up, you'll begin to see the magnetic fields and how they interact with each other, which is really a great visual for understanding magnetic fields. And then, within the first couple of chapters, students are going to be wiring up and hooking up some circuits in a safe manner and beginning to learn some of the differences between both AC and DC electricity. And let me show you how. So right here we have a transformer, a step-down transformer, that is converting the 120 volts coming into here over to about 15 volts. I'm going to plug this into a lamp off of the AC side after it describes a little bit about what AC voltage is. Plug it into here. We have a power button right here, which will activate the power to the circuit, to the AC transformer, and you can see the light up. All right? And then within this experiment, they will also learn the introduction to transformers and how less voltage equals less power. They'll go to the center tap on the transformer here, and they'll see that the light bulb is dimmer. Okay? And then they will convert pretty quickly from there, and again, just using hands-on, interacting with electricity. They'll learn deeper into the theory later in the manual, but they'll actually run from the transformer into a bridge rectifier, and then it describes how every power outlet that charges a phone, charges an Xbox, a Nintendo Switch, whatever, uses a transformer into a bridge rectifier to convert it to DC voltage, okay? And then we'll run that into the DC side of the system and see what effect that has on the light, okay? This light bulb happens to be able to be powered up by both AC and DC. And then seeing the effects of the voltage when you run less to the bridge rectifier, okay? Showing the example of how the light works, okay? You'll also be able to set up some basic experiments of running loads in series and parallel. Here's an example where you can just run the lamps in parallel to light them both up. Okay? And so now you can see that both of these are receiving the same DC voltage from the bridge rectifier. The power switch here allows you to turn this on and off at any time. If a student disconnects something, there's fuse protection and a circuit breaker here, all meant to protect the system. And then again, even at the beginning, students are going to be seeing motors run and things like that. So we're just going to go ahead, run this over to the motor here, activate the push button, and if you can't see it, you can probably hear the motor actually spinning, okay? And we can talk about that circuit. And then you can progress and create whatever circuit you need to. So for example, you can go ahead and run this over to a slider switch. So then when it's on, the students can learn about how slider switches and how continuity is important and how you have the basics of every circuit. So you have your power supply, means of transmission, your load, and then the fourth thing that doesn't have to be there but oftentimes is a switch like this. Okay? And so students are interacting with these things, so they're learning the terminology. They're understanding how all of these things interconnect before they really dive into like the theoretical stuff using some of the resistors and capacitors and transformers to really kind of get an idea of exactly what's going on in the system. So this is very, very functional. All right, let's go ahead and run a little more complex experiment so you can see how far the students will take it. Okay, so the trainer comes with a 12-volt DC relay, all right, that goes into a relay socket from the bridge rectifier over to the switch. From the switch, from the contact on the switch, I'm going to go to the coil. From the other side of the coil, I'm going to go to the ground on the bridge rectifier. So now I have a circuit that's very similar to what we had hooked up here in the motor, but in this side, instead of a rotational movement, we're creating electromagnetic movement with a switch. Okay, so I'll turn this on, and when I flip this over, you'll hear the relay click. That's the relay turning on and off based upon me activating this right here. There's both normally open and normally closed. Contacts here to control this motor. Okay, so now that I have this set up and there's diagrams to show you how to wire all this so the students aren't being thrown to the wolves, I can come over here, activate the switch, which will activate the relay, which will then control the motor. Okay, so this motor can be at a different voltage, either higher or lower than the control voltage here. And students are learning this type of terminology, which is very, very useful for the future. Students will also begin to use the analog meter, not only learning how to read the analog meter, but also how to verify in math when you get to the later stages of the manual, when you're learning about Ohm's law and things like that. So what we would like to do is we like to show them the math and then prove to them that the math is real, okay, and that it's correct. Plug this in here. The needle is moving and it's going to be reading right around 12 volts DC, okay? And then from there, you can begin to set up current measurements based upon resistor sizes. You can build series and parallel circuits within these, not only off of a 6 volts coming from a battery, but also from the bridge rectifier. There are a number of components built in, including potentiometers, slide switches, transformers, so they can learn the difference between step up and step down, and then different semiconductors, including op amps, transistors, Zener diodes, all sorts of things, regulators, all sorts of different components that they'll see at the electronic level, and then later on be able to transfer in to any electrical or electronic class that they take. Okay? And then the great thing about this is once the experiment is done, or the class is over, or the students have accomplished the objectives of the day, it is very easy to go ahead and put away. You can choose to put the stuffing back in there if you would like. If not, this thing is ready to go. Lift it up. It's compact. It's in a tough container, so you know it's going to last quite a long time. So if you have any questions or want to learn more about the MB100 Principles of Electricity Trainer, please contact your TII Technical Education rep or follow the link in the description. Thank you so much for watching, and I hope you enjoyed it. This has been Pat Cleet for TII Technical Education Systems. For more information on this trainer and trainers like this, please visit us at tii-tech.com. Hope to see you soon.